Hello folks, we are back with our exercise 6.2. Last class we were doing the problems on increasing, decreasing. So we'll be continuing with those set of problems. We have done like different category of problems. So also we continue with that. We finished with the 9th one. Now we'll take the 10th problem. What does the 10th problem say? The 10th problem says that prove that the logarithmic function is strictly increasing on 0 to infinity. Pretty easy actually. It's a kind of 1 mark kind of problem. Now very small, hardly anything to do. Like you've got to show that log x is strictly increasing on the interval. Also they have specified. I told you that if the interval is specified, makes our work much better. So that's about it. The problem number 10. So let's take the problem number 10. Let's see what it says. They tell us that it's a logarithmic function. So maybe because they haven't given the f of x, let's call f of x as log x. So our function is log x. They have asked us to show that log x is increasing on the interval from 0 to infinity. Obviously, our first step is going to be to take the derivative. So let's take the derivative. What happens if we take the derivative f dash x? Log x derivative is 1 by x. We all know it, that the derivative is 1 by x. So derivative is done. Our next step is to show that it is increasing on 0 to infinity. It's pretty easy actually, hardly anything. It is increasing. Let's see why. See, the x is between 0 to infinity. So definitely x is positive. So here we know that x is positive. If x is positive, 1 by x is definitely going to be positive, isn't it? 1 by 2, 1 by 10, 1 by 100, 1 by 1000, 1 by 5000 or 1 by 5022, something like that. They're all going to be positive. So that's pretty like rest assured. So therefore 1 by x is always greater than 0. Why? Because x is greater than 0. Then in that case what it means? It means that f dash x is greater than 0. Not everywhere, only when x is when x belongs to 0 infinity. That's it. So therefore given function is increasing. That's it. They want us to show only that. That's about it. So that's, as I told you, pretty like 1 mark or 2 mark problem. Nothing like no great deal, right? So we can quickly move to the 11th problem also. What does the 11th problem say? 11th problem gives us a function. It gives us f of x as x squared minus x plus 1. It gives us a function x squared minus x plus 1, but it is like the question is worded slightly differently. What they're telling that you just show that this function is neither increasing nor decreasing in minus 1 1. So again, interval is there, so your work is much relaxed. Anyhow, derivative is an inevitable step, so let's go for the derivative and then we will build up whatever that they are asking us. So let's get to the derivative f dash x. Derivative of x squared we all know is 2x, and derivative of x we know it's 1, so 2x minus 1. Basically the answer lies over here. Though they have not asked the critical point, we'll just look at the critical point for us to understand why this problem is behaving like this. Suppose if we will look at the critical point, as I told you, it's not required, but this is just for us to analyze. If this is 0, then 2x minus 1 is 0. So 2x is 1 and x is half. So half is the critical point. Now they ask us to look at the interval between minus 1 and 1 and tell that it is neither increasing nor decreasing. When it is neither increasing nor decreasing, what we are going to do is we are going to choose 2 points, where in one point the f dash value will be positive and in one point the f dash value will be negative. That's how you show that it is neither increasing nor decreasing. So that's going to be our line of action. So therefore, and why that is happening? Because in that interval from minus 1 to 1, this half is coming, critical point is coming. Generally how we will take, like I hope you're able to understand, it's minus 1 to 1 that they're asking us to check. Half is coming, like 0 could be here, half is coming here. So as a result, generally what we do for the critical point, we'll take one interval that side, one interval this side. But because you're trying to take an interval, that doesn't accommodate it properly, that is why this problem is coming. Okay, so as I told you, this is totally optional. There is no need to do it, it's just for you to understand. Alright, so since they have told us about the interval, so let's look at the interval in minus 1 1. Okay, let's look at the f dash value. f dash. One negative value, one positive value. We'll just check whether it is working fine. Maybe f dash at minus 0.2 or 0.1 or something like that. F dash at minus 0.2. Let's see how the answer is. Will be 2 into minus 0.2 minus 1, which is minus 0.4 minus 1 minus 1.4, which is less than 0. Okay, but if we look at some other value, that is f at maybe say 0.7 or 0.8, what will happen? F dash, not f dash. At 0.8, it is 2x minus 1, so 2 into 0.8 minus 1, which is 1.6 minus 1.6, which is positive. So in that specified interval, at one point the function's f dash value is less than 0, but at the other point the f dash value is positive. So that is the problem. That is why it is neither increasing nor decreasing. So therefore we'll say that in minus 1 1, the f dash x is positive and f dash x is negative at certain values. Hence, it is neither increasing, only in that interval. If you choose the interval properly, then we'll be able to show that it is increasing and decreasing, nor decreasing in minus 1 1. So that's about it. So that's how it's quite logical, but then yes, this is how the thing has to be. So that's all about. It's quite simple, both the problems. That's all about this. With more problems, we are meeting in the next video. Thank you.